Hi everyone, my name is Sai Pranay. I'm a physics lecturer. I would like to explain the intermediate physics. Apart from that, I am starting the intermediate first year physics. From that, I have selected the second chapter, which is units and measurements. This chapter will provide the 2 marks in the IPE examination. But in the MSET and NEET and JEE level, this chapter will provide the more knowledge and provide the more marks. Based on this chapter only, further chapters are giving the more marks. Means based on these principles, based on this concept, we are able to write the units and dimensions for the further chapters. Okay. So I would like to focus on the units and measurements. First of all, we have to know what are the units. In the general life, we are using the units actually. For example, I am speaking now. Decibels. The sound is measured in the decibels. And we are using the word kilometers and meters and centimeters for the distance and length. For the temperature, we are using the kelvins and degrees Celsius and Fahrenheit also. And for the weight, we are using the grams and kilograms like that. Okay, these kind of units are we are measuring. But in case of the olden days, when we are going to the olden days, in India, we are using the word for the measuring the weight. We are using the word share, other share, pow share, like that. For the weight, we are using the word share in the olden India. But in case of the Western countries like European countries in the olden days, they are using the word to measure the weight called pound. They are using the word pound to measure the weight. They are measuring the weight in the terms of pound. Like the differences are there. Our share is not equal to the pound actually. These kind of differences are there. To overcome these differences, to overcome these problems, the system of international is invented. System of international is invented. Actually, we are having the 4 types of units: FPS and MKS and CJS and SI. This SI is the system of international. Now we are following that only. Nowadays we are following that only. Actually, FPS is the, for example, for the FPS, you have to understand F for feet to measuring the length, distance, feet, F for foot in the plural feet, P for pound to measuring the mass, measuring the mass. S is the second to measure the to measure the time, to measure the time. And coming to the MKS, M for meter, M for meter to measure the length as well as distance. K for kilogram to measure the mass, to measure the mass. S for second to measure the time, to measure the time. C for centimeter, C for centimeter to measure the length, as well as coming to the G, G for grams, G for grams to measure the mass, and coming to the S, coming to the S, seconds. That is nothing but time here. Okay, these kind of methods are there. Actually, I have said before this terms something about this. We are facing some problems when we are changing the countries, when we are changing the regions, when we are changing the places. Differences are there. To overcome these differences, system of international is invented. System of international is invented. Okay. Through this, we are able to maintain the standard units across the world. Anywhere you go, we will get the same units only, same phenomena only. Okay. So this is the major concept of the units. Okay. And coming to the physical quantity, coming to the physical quantity. Actually, physical quantities. What is the physical quantity? Physical quantity, a material or a system which can be measured, which can be quantified. Means, for example, this is a pen. It's having the length, it's having the diameter. This is able to measurable. These are measurable, okay, with some instrument. And physical quantity is a material or a system which can be quantified. Quantified means which are able to measurable. We can measure that. Okay. Now this physical quantity will explain the laws of the physical world. Physical quantity will explain the laws of the physical world. Okay. And based on the SI system, these physical quantities are distinguished into three types. Okay. They are physical quantities are distinguished into how many types? Three types. These three types are there. They are: first one, fundamental physical quantity; second one, derived physical quantity; third one, supplementary physical quantity. Fundamental physical quantity means the physical quantity which is do not depend on the any other physical quantity. Understand? The physical quantity which do not depend on the any other physical quantity. They are independent. They are not depending on any other physical quantity. For example, length. Length represented by L. Represented by L. This is not depending on any other physical quantity. And time, mass, represented by M. Represented by M. And time represented by T. Actually, 7 fundamental physical quantities are there. I will write later. Basically, we are using these terms only frequently. Okay. Length, mass, time. They are fundamental physical quantities. More 4 are there. I will explain later. Now, these three terms are not depending on others. Okay, not depending on others. So they are independent. These kind of independent physical quantities are known as fundamental physical quantities. Fundamental physical quantities. Now coming to the derived physical quantity. Derived physical quantity. What is the derived physical quantity? The derived physical quantity is a physical quantity which are depending on the fundamental physical quantity. They are not independent. They are dependent. They are depending on the fundamental physical quantity. Understand? For example, area. Area. What is the formula of the area? Length into breadth. Length into breadth. Length is measured in the terms of L only. This also breadth is measured in the terms of L only. From this only we will get this. From this only we are getting this. So the area is made up of the length only. Actually, the area is made up of the length only. Means this length will help to measure the area actually. Means from this only we are getting this. Understand? From this term only we are getting this formula. Means this is depending on this term. So this is not independent. This is dependent. Okay. So this is depending on this term. So this is the derived physical quantity. Understand? Now coming to the volume. Volume is length into breadth into height. The length is represented by L, breadth also represented by L, h also represented by L. So this is nothing but L, length only. So this term is obtained from here. Means this formula is depending on the length only. Again it is depending. So this is the derived physical quantity. Okay, derived physical quantity. For example, we have to take the velocity. What is the formula of the velocity? Displacement by time. Displacement by time. Displacement nothing but what? Length only. Displacement nothing but what? Length only. Time is nothing but you are representing with the term of t. L and t are from where? Fundamental physical quantities only. L and T are from fundamental physical quantities only. So they are depending on the fundamental physical quantities. So this formula is obtained from the length and time. They are belonging to fundamental physical quantity. Indirectly, this velocity is depending on the length and time. So this is also a derived physical quantity. Derived physical quantity, like force and work and power. These kind of terms, entire terms are derived physical quantities only. Now coming to the supplementary physical quantity. Actually, this is also a derived physical quantity, but some difference is there between these three. What are the examples of the supplementary physical quantity? There are two types of the supplementary physical quantity. First one is plane angle. Plane angle. Second one is solid angle. Solid angle. Plane angle and solid angle. They are the supplementary physical quantities. Why I am mentioning them as separately means they are not having the dimensions. These are having the dimensions, but these physical quantities are not having the dimensions. Supplementary physical quantities are not having the dimensions. Okay, they are dimensionless quantities. Dimensionless quantities means which kind of physical quantities are not having the dimensions? They are known as what? Dimensionless quantities. In the further concept, we are going to learn the dimensions. Okay, I think this is clear to you. Okay. Now I would like to write the 7 physical quantities which are fundamental. Okay, fundamental physical quantities. Fundamental physical quantities. First one, mass, represented by what? M. Represented by what? M. Okay. And the units of the mass is in the SI kilograms. Okay. Units. Symbol. Physical quantity. Simply I am writing PQ. Okay. Second one is length, represented by L. Represented by L. SI units are meter. Okay. Now third one is time, represented by T. Now this is measured in the second. Okay. Now fourth one is the electric current. Okay. Electric current, represented by what? I. In somewhere they are represented by A also. Okay. Units ampere. Fifth one, temperature. Temperature, represented by the term T also. Now we can measure in the SI units, it is Kelvin. The units of the temperature is Kelvin. Now for the symbol we are using K or theta also, or theta also. Now sixth one, luminous intensity. Luminous intensity. The units are candela, represented by C. Represented by C. Seventh one, amount of substance. Amount of substance or quantity of substance also. The units are mole. Units are mole. The symbol is MOL. The dimensions we are using like this. For the dimensions we have to use like this. Brackets. Okay. These are the fundamental physical quantities. How many are there? 7 are there. First one is mass, second one is length, third one is time, fourth one is electric current, fifth one is temperature, sixth one is luminous intensity, seventh one is amount of substance. Okay. Now these are the symbols, these are the units. Okay. Now I would like to explain about the derived physical quantity. Derived physical quantities. Derived physical quantities. Okay. First one, area. Formula of the area, length into breadth. Okay. Length into breadth. Okay. And length is nothing but L. Breadth is nothing but L. L into L, L square. And this power is there, no? This power is the dimension. Okay. Here we have to know dimension. Dimensions are measuring in the terms of powers of these terms. Okay. Powers. Okay. Understand? These powers are the dimensions here. Now we can write here, we are mentioning only the length of jelly. There is no mass and there is no time. How we can write them? We can write the mass and time here, but we should not write 1, 2 like that. We have to write zeros on this place. Okay, zeros on this place. That means nothing but m power 0, l power 2, t power 0. Means there is no mass, there is no time, only length is there. Now in the exam they will ask like this: what are the dimensions of the mass in the formula of the area? What is the dimension of the mass? 0 here. Okay, we can write 0. What is the dimension of the length? 2. What is the dimension of the time? 0. Okay. Now coming to the second example, volume. Coming to the second example, volume. Okay. That is length into breadth into height. Length into breadth into height. What is the term we are using to represent the L? That is L only. What is the term we are using to represent the breadth? That is L only. What is the term we are using to represent the H? L only. Now simply L cube. Okay. Now you can write like this. There is no mass. M0 L to the power of 3, T to the power of 0. Understand? Then what is the dimension of the length here? 3. What is the dimension of the length here? 3. We have to mention in this bracket like this. Okay? Here also. Now third one. Third one. Density. Mass density. Okay. Mass by volume. Mass by volume. What are the units of the mass? Kilogram. What are the units of the volume? Meter cube. And what are the terms we are using to represent the mass? Here you have to understand what is the which term we are using to represent the mass? M. So you have to write like this: M. For the mass you are using the word M. For the volume you are using the word volume, L cube. Simply you can write L cube here, the term of volume. Okay, L cube. Okay, here plus 3 in the denominator. When you are sending this term to the numerator, it will become minus. Okay, M L power minus 3, T power 0. There is no T, that's why I am writing T power 0. Okay, understand? Now Coming to the velocity, that is displacement by time. Displacement by time. What are the units of the displacements? I am writing the units also. Okay, like this. Here I didn't write the units. I forgot, but I am writing here. They are simple only. That's why I didn't write. But here I am writing. So for the displacement, units meter. For the time, second. Meter per second. Simply we can write like this: meter per second. Centimeter per second also there in the terms of CGS. Okay. Now for the displacement, this is the length actually. Displacement is nothing but length. For the length you are using the word L here. Understand? Which letter you are using? L. For the displacement, you have to write the L. For the time, you have to use T. Understand? You have to use T. Now, T power what here? 1. L power 1. So, L power 1, T power. When you are sending to the numerator, it will become minus. So, this is the dimension of the velocity. And in another way, m power 0, L power 1, T power minus 1. Because there is no mass, that's why I am writing m power 0. Okay. Now, coming to the speed, fifth one. Coming to the speed, okay. Speed also similar to velocity. Let us write distance by time. What are the units? Same, meter per second only. Distance is representing in the terms of what? Length. Time is representing in the terms of what? T. Okay. Now, similarly, you have to write like this: T power minus 1 and m power 0, L power 1, T power minus 1. Okay. Here you have to observe the both are same. Which physical quantities are having the same units, they are having the same dimensions. Now we have to notice that. Understand? The physical quantities are which are having the same units, they are having the same dimensions. Understand? Okay. That's why I am writing here units. To mention this note, that's why I am writing in here the units. Understand? Now, speed icon. Okay. Next. Acceleration. Acceleration. Acceleration formula is represented by velocity by time. Velocity by time. Now, units meter per second square. And the dimensions. What are the dimensions of the velocity here? Velocity, you have velocity. Simply you can write here instead of velocity m power 0, L power 1, T power minus 1. For the time you have to write T. Understand? Here T power 1 actually. When this 1 go to the upside, it will become minus. Minus and minus 1 and minus 1 becomes minus 2. So m power 0, L power 1, T power minus 2. Okay. So this is the dimension for the acceleration. Now you have to understand what is the dimension of the length for the acceleration. What is the dimension of the length for the acceleration? L power what? 1. If they are asking about only length, you have to understand that is 1 only. If they are asking about complete acceleration, you have to say this. Otherwise, if they are asking about the time in case of the acceleration, you have to say minus 2. If they are asking about the only mass for the acceleration, you have to say 0. Understand? So these terms are playing more key role in the physics. Okay, that's why you have to understand. If I am asking about only mass for the acceleration, 0. If I am asking about only length for the acceleration, that is 1. If I am asking about only time for the acceleration, that is minus 2. If I am asking about complete acceleration, then you have to say this. Okay. Now coming to the force. Force. Okay. Force is equal to m into a, mass into acceleration, our formula. Okay. Now what is mass? We are represented by what? Mass, m. For acceleration, already we got about the acceleration. Just you have to substitute here this value for the acceleration. Mass we have wrote m. For the acceleration you have to write this term. Okay. M power 0, L power 1, T power minus 2. Okay. Actually you got m. So you can derive this. Now you have to write m L T power minus 2. M L T power minus 2. Simply you have to remind this. This formula will very helpful to you to find more dimensions. Okay. MLT power minus 2, MLT power minus 2. Remind that. Okay. Now force, we got force. Now you have to understand momentum, linear momentum. This is linear momentum. Linear momentum that is represented by P. P is equal to mass into velocity. P is equal to mass into velocity. So what is mass here? M. What is velocity? You have velocity, right? This L power 1, T power minus 1. Simply you can write. There is no need to write the 1 again and again. If you are having the minus, you have to mention that. Okay. Now M L T power minus 1. This is for what? Linear momentum. Okay. Ninth one. Work. W equal to what? F dot bar S bar. The dot product is there between the two vectors actually. When you are removing this, you will get the Fs cos theta. This theta is the supplementary physical quantity. I have said before 2 minutes actually. Theta is a angle. The angle is not having the dimensions. So this is a supplementary physical quantity. That's why no need to write this. So that's why simply we are writing Fs. So what is F? Force. For the force you have mlt power minus 2. Instead of force we have to write mlt power minus 2. X means what? Displacement. Displacement is what? Represented by L. So here L power 1, here L power 1. Both are same. So L into L, L square. You have to write M L square T power minus 2. So this is the dimension for the work. This is the dimension for the work. Now we have to write more dimensions. Okay. Now which one? 10th one. Power. Power is what? Work by time. Work done in the unit time. Okay. What is the work? What are the dimensions for the work? Simply you can write this instead of work. Okay. Write that m L square T power minus 2 by time T only. M L square T power minus 2. I have wrote instead of the work. For the time you have to write T only. Now T power 1 here. If it is going to the numerator, it will become minus. Minus 2 plus minus 1. Here what it will become? Minus 3. M L square T power minus 3. Okay. So this is the dimension for the power. This is the dimension for the power. Now I would like to write the dimension for the energy. I would like to write the dimension for the energy. Already we wrote the dimension of the energy. Where? For the work. According to work and energy theorem, they both are same. Okay. Work is nothing but energy, energy is nothing but work. So the dimensions of the work is similar to the energy. If you want, I will check again and again. Actually, how many types of energies are there? Mechanical energy. In case of mechanical energy, number of energies are there. I am taking the mechanical energy actually. Mechanical energy is the combination of the potential energy and the kinetic energy. So first of all, you have to write the kinetic energy and second one potential energy. Okay. Now kinetic energy. What is the formula of the kinetic energy? 1 by 2 mv square. These are numericals. No need to write the dimensions for this. Okay. Now what is mass? M. What is mass? M. And what is V? Velocity. What are the dimensions of the velocity? This one. You have to write this only directly. M power 0, L power 1, T power minus 1 square. Instead of V, I have wrote that and applying the square. Now you have to write M. So it will become again M0 only. So L power 1 into 2 L square, T power minus 1 into 2 minus 2. Is it similar to this work? Same. ml square T power minus 2 ml square T power minus 2 for the kinetic energy. Now you have to check for the potential energy. Okay. What is the formula of the potential energy? mgh. Okay. M for what? Mass. G for what? Acceleration. Which acceleration? Gravitational acceleration. The dimensions of the gravitational acceleration, the dimensions of the normal acceleration, they both are same. So that's why I am applying the dimensions of the acceleration for the gravitational acceleration. Okay. Now same you have to apply m power 0. There is no need to write the m power 0 and again here. Simply I write directly L power 1 T power minus 2. What is h? It's nothing but length. Okay. L. Now L and L into L square, L square T power minus 2. Are they same? Ml square T power minus 2, Ml square T power minus 2, Ml square T power minus 2, Ml square T power minus 2 means the energy, the dimension of the energy is similar to the dimension of the work. Understand? Now you can write the dimensions for the any kind of energy right now. Okay, based on this. Okay. In the further video, I would like to explain about the angular concepts, angular velocity, angular frequency, torque, like that. For that, I will write the dimensions. We will meet you in the next video. Thank you for watching.